we are discussing about the conductivity and resistivity of rocks. When we are going for electrical resistivity method or electrical prospecting of survey, we must know that the rocks contain mineral and also traces of salts and water. Some rocks are dry and some rocks contain these minerals and salts and water also. So these electrical methods depend mostly on the electrical conductivity of different rocks and minerals. When you take some examples, certain minerals like pyrite are very good conductors of electricity, and many other ores which are like present in the rock, which are having some minerals, they have low conductivity, and non-metallic minerals are also bad conductors of electricity. So when we are passing a current into the ground through the resistivity meter or any kind of a source, the ground will distribute the current itself according to the conductivity of the rocks and the minerals that are coming under the influence of the current. So when you are sending current like this, when you are sending the current here in, say example, this is a rock and you are sending the current into the ground, then the conductivity will allow the current to pass through the rock. If the resistance is more, then the current flow will be less. So this depends mostly on the properties of the rock and also the type of salt that is added in this or the type of moisture that is present inside. So from this we can understand that electrical resistivity or electrical conductivity is a physical property of this material that is being used in the electrical method. Now we will discuss about the conduction in the rocks first. We have three different types of conduction. One is metallic conduction, and the other is ionic conduction, and then dielectric conduction. These are important to understand the behavior of the rock during any kind of electrical survey. So the conduction of a current in any medium is molecular property. So all the molecules will work and they conduct the electricity. So based on that, we have these three kind of conductions. So let us discuss one after the other. So in the first, metallic conduction, this type of conduction is mostly in the metallic bodies. This is due to the conduction of current by the electron motion. Just like you saw here, the electrons positive and negative charge, because of the movement of these electrons, you have the conduction. And this is when you take certain minerals, they have a good conductivity compared to the metals. For example, if you take sulfides like pyrite and some other materials like graphite and magnetite also, the resistivity of these conducting materials is like 0.1 ohm meter. But they are present in the rock, so they may be found to be more resistive because of the imperfect contact between the individual crystals. So if you see when the contact is not proper between the crystals, then you'll have more of resistance. So the greater the number of imperfections, the higher will be the resistivity of the metal. And next we'll discuss about the electrolytic conduction. So you see here this type of conduction is taking place in electrolysis of solution due to the transport of ions. So because the mobility of ions, the current is carried out. Here you can see the current is being carried out through the ionic changes. The conductivity of salt solutions and other like electrolytes is partially or completely electrochemical. So when a rock contains uh, NaCl, sodium chloride solution, the conductivity will be different. When it is containing potassium chloride, it is different. So based on the type of the salt or when the water contains very less or no salt in the rock, then the conduction will be different. So that depends on the chemical process. This kind of conduction is also called as electrochemical conduction because of the presence of the chemicals. Most of the rock formations conduct electricity because they are having mineralized water in their pores and cracks. If not, they are completely highly resistant also. So in general, when you take a dry formation, which is completely dry, something like a packed rock or a igneous rock, the resistance will be like all the rocks and soils transmit the current due to the presence of water in the pores. But if the formation is dry, then the current passage will be less. That means the resistance will be more. So, in general, the resistivity of any formation can be considered as the function of porosity. So, you must understand the porosity, the saturation, and the salinity of the water. Based on those things, the resistivity will vary, and then the resistivity of water will decrease with the increasing salt content also, because when the water doesn't have any kind of salt, so then the resistivity will be uh, changing. But when the water resistivity will decrease when there is an increase in the salt content, that means the current flow will be easy. And next we are going for the dielectric conduction. This type of conduction will take place in rocks and minerals that are having high resistivity, that too in the presence of an alternating current. So when we are giving the current during a resistivity survey, we do it in two methods. One is direct current method, the other is the alternating current method. We'll discuss about that in the coming videos. So in these minerals, there are no free electrons or ions to provide any conduction, but the limited displacement of the charged particles. See, you see here, it is plus, minus and plus. So that means we are giving a charge, and that displacement of the charged particles permitting the conduction of alternating current on the surface of these materials. So when you see the orientation molecules, when an electric current is applied, so that may also cause a dielectric polarization. So this is about the conductive properties of the rock. So as we have discussed, metallic conduction and ionic conduction and dielectric conduction. Now we'll discuss about the resistivity of the rock. So resistivity is also one of the physical property of any substance. It can be a pipe, wire, rock, water, or anything, even the drilling mud also. This is a property, and when you are defining this one, it is actually the resistance that is offered for the flow of electric current. So if you are taking a unit volume like a unit cube or something, when the voltage is applied across these spaces, the resistivity is expressed in ohm meters, because the length is involved and the distance is involved. So we are taking as ohm meters or ohm feet or ohm centimeters also. This parameter is independent of the size and shape of the object or the substance. So the resistance offered by a substance is a function of the resistivity, size, shape, and points of the measurement. So wherever you are taking the measurement, there you will have a different resistance value. So when you are going for an electrical survey, if you take the point here, you will have a different resistance. When you go shift the location to the other point, you'll have a different resistance. When you go to one location, that will have a different resistance. So that depends on the location also, and the size and shape and the points of measurements. So you should understand, like in a single place you might have different kind of resistance values, or when you go deep also you'll have different kind of resistance values. Based on that only we can identify the oil and gas, minerals, water, all those things. So we just take an example of a cylinder, and the resistance offered by a substance with some regular shapes like this kind of cylinder, or parallelly open cubes, that can be determined by R equal to rho into LA. Here R is the resistance and the rho is the resistivity. So if you want to find out the resistivity, then This will go here R into A by L. Okay, so that is how it will work. And then you have, if you want to know the conductivity, you must inverse the resistivity value. 1 by rho A will be the conductivity. While measuring the resistance, we will come across two factors called true and apparent resistivity. This is very important to understand because when you are going for a survey, you will be mostly recording the apparent resistivity and then you will be plotting the graph accordingly. So we are discussing about the true and apparent resistivity. Any geological formation, they possess one property, like we discussed earlier, it is electrical resistivity. So this geological formation is having different kinds of layers from the top to bottom, bottom to top. For example, if you take this as a homogeneous, that means a single layer is present all the length, then the resistivity that is measured will represent the true resistivity. Say example, if I take a resistivity of this particular block, then I will get the true resistivity. If I say this is homogeneous, that means it is all same from top to bottom without any kind of impurities and all. But when you go to the field, you will be coming across the apparent resistivity. That means the apparent resistivity of a geological formation is equal to the resistivity of the fixtures homogeneous and also the isotropic medium in which a given electrode arrangement, that means the electrodes here A and B are electrodes. If you keep on increasing the values, then the resistivity will change and the current strength and the potential difference. Here the potential difference is measured at M and N. So the apparent resistivity will vary on the current electrode separation and the potential difference that is measured here in any homogeneous medium. So we say that apparent resistivity depends on the geometry and the resistivity of the elements that are given in the geological medium, and it does not represent any average resistivity. It can be a lower value and also a higher value. So when the current is passing under or deep inside, the apparent resistivity value will change. Based on that, we'll be plotting different graphs and then we'll be finding out the geological strata or groundwater, or we can identify the minerals. And now let us discuss about how the electrical conductivity or the spatial distribution of the electrical parameters are determined. So when it comes to the electrical conductivity, we are sending the current into the ground through these current electrodes and we are measuring the voltage here. So the current is going down into this and then the potential difference is measured here, and this measurement we can say like the measuring resultant currents are indirectly by measuring the associated magnetic fields. So there are two, three ways of finding the conductivity of a particular area. That one is resistivity method, the other is telluric currents also. So we'll discuss about that in the next videos. So when we are giving the current, the atoms or the molecules or the ions that are being excited, and this excitation is done through a source here. So when we are sending the current through a source, then we are getting the values. So we can see this is a inhomogeneous place, and in this place, the excitation is strongest around the source. That means when the source is near, you have a higher current passage and higher activity in the uh, atoms or ions. But when these electrodes are going far away from the source, the excitation will decrease. So whenever the excitation reaches to any place or any longer distances, it will affect the measurement. So that is why we are shifting the potential electrodes also in some resistivity methods. So the influence of a particular piece of ground that is close to the source and the setup has a strong measurement, and which are far will have a low measurement. So averaging on the extended volume of ground results in smooth change in the measurement, even if there are sharp changes in the physical properties, and that forbids an exact determination of the distribution of parameters. Therefore, this particular topic is mostly related to the interpretation. Therefore, the interpretation of the observed results goes invariably with the gross idealization of shape of the inhomogeneities and their physical properties. So that is why when you are going for a survey and the interpretation of electrical measurements must rely on the available geological information. That means you should understand the geology and you must gather the information of this geology before you go for a survey. Even the geological knowledge is important while carrying out the measurements. So in the next video, we will discuss about the classification of electrical methods and how we do the electrical methods.